There's been a lot of hype around the NCASE M2, and for me, I think this time around I've been feeling a little more skeptical. And that's because while I liked their previous M1 Evo, as time went on I started to feel like it didn't quite deliver on its promise. The build process was unnecessarily complicated. There were some fairly obvious missed cooling opportunities, and the lack of true compatibility with the Founder's Card, as it was implied in their marketing, was very frustrating. Later, they did come out with a revised back panel that kind of supported it, but it was an additional cost for V1 owners, and it all became just very confusing. Which makes sense why they decided to call this new version the M2, instead of something like the M1 Evo V2, which would have probably made things even more confusing than they already were. Now, the promise of the M2 is really the same as the M1 Evo was, but it looks like they might have actually gotten it right this time. And that's to have all the versatility and component compatibility one could reasonably hope for in a relatively small 15.6 liter case. If you wanted to prioritize GPU cooling, you can have the flipped config, or swap around the tray in the back panel to have your classic reference layout. There are a few different price points depending on what front panel design you choose. So the cheapest option, which is the black round version, is only $165. That is a great price considering the quality of materials used here. But what's really strange to me is that the starting price for the next one up, which is the angle design, is $40 more. That's a very large 25% increase just to have a couple of slanted cuts on the front panel. And look, I totally understand that more CNC machining time costs more money, but $40 more? And if the design costs that much more, why is the opposite true for the M1 Evo? The M1 Evo angle is $10 cheaper than the M1 Evo round. I truly don't understand. And no, none of the designs come with any additional accessories or anything like that. Actually, the most expensive version, which is the greater design, comes with less. It doesn't include front I/O, so keep that in mind when you're making a decision. But at least the price difference, it kind of feels like it makes more sense considering how much more intricate the design is. Now, speaking of additional accessories, there are a few that you might need to pick up in addition to the base price, all depending on the configuration that you want to go for. Things like the extra radiator bracket, vertical GPU riser, all of that, fair enough. But also, if you want to use an ATX power supply, you need to dish out an additional $15 to do it. Now, that one is a major bummer. I would have much preferred to see a bracket that's either universal or both versions in the box, as that really does cut down on the potential savings that one would get from going with an ATX power supply instead of an SFX power supply. Now, with all that said, I actually do think $200 is a reasonable price for the quality that you're getting here, but $165 is a great price. So when you pick this up, it's either going to come flat packed or you have the option to buy it fully assembled if you want to pay a little bit extra on a few of the designs, but those are basically always out of stock. So let's just put one together and see what the process is like. Now, taking everything out of the box, I was really surprised to see that the I/O is already installed here. And this I/O piece is a significant improvement over the mess that you had to deal with on the M1 Evo. Now, before, the spot directly to the left of the power button was used as a second front Type-C connector, which sounds good at first, but the problem is most motherboards only have one USB-C front panel connector. So what you would have to do is buy an adapter to use it, which I really don't think anybody did, so most people got stuck with either a hole or an unusable USB-C connection. So now they turned it into an indicator light to maintain that symmetrical design and put that empty spot to use. If you built with the T1 or any other cases from NCASE before, the quality feels, largely the same, maybe even slightly better. The finish is definitely smoother than my T1 version 2.1 or my M1 Evo. The top panel and the side panels, they look a little thin, but they're actually quite rigid. I don't really think you're gonna run too much risk accidentally bending these with normal use or anything like that. So yeah, a few pieces to sort through here, but probably the most complicated piece is the motherboard tray. Now, if you're a new builder, looking at the overwhelming amount of holes would likely be pretty intimidating. This section along the side is for the motherboard standoffs, so if you're using an ITX board, you have multiple vertical positions where you can mount it. Now, where on the axis that you mount it will largely depend on the configuration that you're going for. I want to try a couple of different setups another time, but if you are using a micro ATX board like I am today, there's only one position. So let's take out the 8 motherboard standoffs and M3 screws. Now we got to find where we're going to put these standoffs because they don't actually mark them. I think they should really consider marking these holes so that it makes it a little bit more obvious, but you can pause this video and see where they are if you need to. Now, I have criticized NCASE for the confusing bag of screws that were included in previous versions of their cases. There were different types of small screws that could easily be used in the wrong place, but thankfully they designed this one almost entirely around a single M3 screw. This is going to make for a much easier build. Now, there's a bag of countersunk and a bag of flat M3 screws. The flathead ones are designed to work on both the regular or the countersunk holes. So basically it's rendering the countersunk ones optional in most of the steps. So this is going to be easier to assemble if you use a magnetic screw head, like the one I'm using here from this video sponsor, Fanttik. So Fanttik recently sent over their Fold S1 Apex screwdriver for me to check out, and I've been really impressed with everything I've used from them so far. It comes in this nicely designed storage box to organize the 20 bits, which makes things much easier to find, and it should work well across all different types of repairs and household needs. Now the screwdriver itself also feels really high quality. You can fold it into 4 different angles to make using it more comfortable, and it has 8 different torque settings along with 2 speed settings that can be controlled by the LED display. The 2500 mAh battery is charged using USB-C, so you can extend work time without needing to recharge it. Now if you are wanting a more compact package, the E1 Max has been my personal go-to electric screwdriver for small electronics. The case holds 50 bits, the driver itself has a built-in LED light, and 2 torque settings and a manual mode. They also offer a precision soldering iron. I actually have some projects coming up myself where I'll be using this. The iron also has a rechargeable battery over USB-C, and it quickly heats to the tinning temperature in only 7 seconds, with different temp levels between 390 degrees Fahrenheit and 840. If you're interested in picking up any of these yourself, then check out the link in the description. Now out of the box, the front panel is set up for the flipped config, which is actually what I'm going to be going for today. But if you want to go with classic, then there's just one bracket that needs to be moved to the opposite side. Next, we just attach the front and back panels by aligning the tabs and then fastening a few screws on each side. Now for the CPU, I'm going to be going with the Ryzen 7 9800X3D. Just for some clarity, I was actually waiting for this to come in while I was working on this video. So you'll see some shots of the build where the motherboard has a 7600X installed, because that's what I had plugged into it at the time while I was waiting for this to arrive. Now these have been pretty difficult to get a hold of, and so considering I just got my hands on one, I haven't had the chance to do any major benchmarking or anything like that. But still, according to all the reviews, this offers the best gaming performance you can possibly get right now, and consumes less power with more performance compared to anything Intel has to offer. As for the motherboard, this is the B650M Aorus Elite from Gigabyte. I picked this up on Amazon for around $180. It's got a decent balance between price and features. We have these massive VRM heatsinks, 2 M.2 slots on the heatsink at the bottom, Wi-Fi 6E, a ton of I/O including USB-C, and a simple and clean design. I've also got terabyte SSD in one of the slots and 32 gigs of DDR5 6000 RAM. Now, let's drop the motherboard into the case and align it to those standoffs we just added earlier. At this point, you can check through the holes to see if you got the positions for the standoffs correct, and if it all looks good, we can secure it. Now for the power supply, I've got to go with the tried and true Corsair SF750. It's been hands down my favorite for the past few years, and I know it's reliable. This is platinum rated at 750 watts, and this will be enough for the specs in this particular build. But I will note that Corsair does have some newer 2024 versions of this power supply that also now go up to 1000 watts. While we don't know what the power consumption is going to look like for the 50 series cards just yet, based off the rumors, it will be more than the 40 series. So if there is any chance that you're considering a higher tier 50 series card next year, I would probably spring for an 850 or 1000 watt if it's within your budget. So let's grab that power supply bracket and then secure it to the unit. All right, so when I was installing this into the case, I couldn't help but to notice a missed opportunity here. Because these are flat cables, you would almost be able to route them directly behind the power supply, but this bracket sits flush up against the front panel. You could kind of force it, and I lightly checked if it would work, and it kind of would, but it's putting way more pressure on the cables than I'm comfortable with, so I really wouldn't recommend doing it. But it would be cool to see NCASE cut out a route for these cables to comfortably pass behind the back of the power supply, especially in this flipped config like this. That would make managing these cables a little bit cleaner. Now for the CPU cooler, you have up to 144.8 millimeters in clearance. According to their site, there's still enough room for a Noctua D12L, which is actually just barely over their spec at 145 millimeters. This was the air cooler that I really wanted the ability to use in the M1 Evo. It's what I personally use in my DNC4, and I love it. And considering that that case is out of production, this could make the M2 a good alternative. But because it is slightly larger than their spec, I am curious to see how much it pushes up against the side panel. So straightforward installation with this. We just remove those default brackets from the motherboard, place our spacers and the brackets, and this actually has the AM5 offset brackets. So if you are on AM5, you can offset the cooler by -7 millimeters, so that is directly over the hotspot. This goes for both 7000 and 9000 series CPUs. Otherwise, for AM4 users, you should just use the 0 offset position. So we can just apply some thermal paste and secure the cooler. Now it's time to install the GPU, and for this build, I'm going to be going with the Founders Edition 4080 Super. Performance on this card is well known at this point. It's been out for almost a year, so I'm not going to talk about that too much. I'm mostly interested in how well it fits, especially after we plug in the 12-volt high power connector. So this card is a 3-slot card at 310 millimeters in length, but you can fit up to a 4-slot card, 359 millimeters in length. So just about any GPU is going to fit in here. So I actually put all this together a little bit differently than the NCASE manual tells you to do. I don't like the idea of putting the back panel on after installing the motherboard and the GPU. I find that to be a little bit of a pain. And I didn't have any problems doing it this way. All I had to do was remove the back piece, slot the card into the PCI Express slot, and then resecure the same back piece and the GPU bracket. If you're going with a Founders card or something at similar dimensions, you'll need to pick up either a very flexible 12-volt high power cable or a 90-degree adapter. Some power supplies actually already include it. I believe a few from Cooler Master do. Or if you're going Corsair, they have cables available separately. With a 90-degree adapter, it looks like it might touch the side panel without putting any pressure on the port. The flexible cable that I'm using here does get pushed up against the side panel more than I would like. So I would recommend going with a 90-degree one if you can. The Corsair power bridge, by the way, that's not gonna work in this combination of components either, unfortunately. Now, because the CPU cooler is so large, we're not gonna be able to use the side bracket either. Instead, we just have to put it at the top. You'll need to use a smaller cooler like a D9L to fit a few fans on the side if you're wanting to do something like that. Which, that's really too bad. Having one fan off to the side of the cooler is something that you're able to do in the Dan C4 again, and it'd be really nice if that option was available here with this cooler. I will note though that NCASE has come out with a wider M2, and that's called the M2 168, which like the name suggests, it can accommodate an air cooler up to 168 millimeters in height. Although, if you were to go with that version, you might as well go with the Noctua D15. I've actually got one of those right here, so let me know if you want to see a build with that. I think it would be pretty interesting to compare this build with a D12L to a D15 build, just to see how much of a difference there is and if it's really worth going for that larger size. So it looks like the top of the cooler does touch the side panel. It's not so bad to where I'm worried about there being any sort of major bend in the side panel or anything like that, but it is worth noting. It does still, technically exceed the recommended CPU cooler height, but then again, NCASE does show this cooler being compatible in their suggested builds. I do want to try to max out the air cooling potential, so I'm going to add a fan as intake on the bottom and then 2 slim fans right above the GPU. This should direct the air from the GPU and the fresh air from the intake through the cooler and exhaust out the back. Preferably, if I was able to add a side fan, I would probably set this up, again, like my DNC4 is, with fresh intake from the back and then exhaust out the side. But because my only option is a bottom fan, I think that the heat will have a hard time escaping being so close to the table. So I feel like intaking from the bottom and then exhausting out the back just makes more sense in this situation. Once those are all installed and plugged in, we can attach the bottom, side, and top panels, and that's the build complete. So let's test out a new game. This is Indiana Jones set to 4K resolution at the Ultra preset with DLSS set to quality, frame generation off, and path tracing off. And the GPU temps are fantastic. They're staying in the mid to high 50s throughout my entire 1-hour play session. Those slim fans in this flip config, it seems to be working pretty well. CPU temps are looking good, averaging in the mid to low 70s. Now I wanted to push the GPU a little bit more, so I turned off DLSS in Black Myth Wukong, I set it to cinematic settings in 4K, and I ran the benchmark. This is a pretty difficult game to run, especially at these settings, even for a 4080 Super. Barely breaking 30 frames, but what I'm most interested in is, again, the GPU thermals. We're still in the low 60s. The highest I've seen it was 62 for a moment. So yeah, the GPU thermals are looking really great. Then to round it out with something more CPU bound, the final is 4K, DLSS set to quality, and then using the ultra settings. The CPU is the hottest here that I've seen at 80 degrees Celsius, but a lot of the time it was sitting in the mid to high 70s, and the GPU is maintaining the same temps as we've seen in the previous titles. So quickly looking at synthetic benchmarks, this is 15 minutes of Furmark. That heated up the GPU to a 67 degrees Celsius max, but was averaging 65 degrees. For noise levels, I have all the fans on the standard profile in the BIOS. During that synthetic benchmark, the noise levels reached 45 decibels, around 1.5 feet from the system. Okay, let's just round up all the positives and negatives here. Great quality materials, great starting price at $165. They without a doubt improved the build process using only one screw, integrated the I/O, and generally having less pieces compared to the M1 Evo. You can basically fit any GPU, and you have a ton of cooling options, whether you want to go liquid cooled with a 280 or air cooled with a pretty large cooler like the D12L. It really is one of the most versatile cases at this size. Cable routing and management considerations are basically non-existent. They basically expect your cables just to be all over the place. I think things like the PCI Express covers and the ATX power supply bracket, that should be included in the box. While yes, I have a 3D printer, not everybody does. And I'm pretty sure that the M1 Evo came with slot covers. Look at this massive gap on the back. I can only imagine what this is gonna look like with a 2-slot card. The pricing differences between the designs just doesn't really make sense to me either. I'm sure they have their business reasons. Those slanted cuts just aren't worth a 25% increase in price. It's also too bad that the most expensive version has no I/O at all. It would be nice if they even added like a single USB-C or a slim power button, similar to what you see on the FF04 or even on the side like they do on their own T1. Overall, this is a massive improvement again over the M1 Evo. It's what the M1 Evo should have been from the start, and I think NCASE knows that. Thanks for watching.